Hello students, welcome back to Chemistry Sport. Today our topic is how to balance a redox reaction. Before balancing redox equations, we must first learn how to find oxidation numbers. If you understand oxidation numbers properly, then redox reactions become very easy. Today we will learn oxidation numbers step by step, and after that we will learn how to balance redox equations. Equation number 1. H2SO4 reacts with HI to form sulfur, I2, and H2O. According to the rules, the oxidation number of hydrogen is usually +1 in its compounds. So, in this equation, we assign oxidation number +1 to hydrogen. Oxygen is usually found in the -2 oxidation state. So, we assign oxidation number -2 to oxygen. According to the rules, the oxidation number of any element in its free elemental state is 0. So, we assign oxidation number 0 to I2, and sulfur on the product side. However, the oxidation number of sulfur in H2SO4 and iodine in HI are unknown. So now, let us find them. First, let us find the oxidation number of sulfur in H2SO4. Hydrogen is +1. There are 2 hydrogen atoms. So, their total oxidation number becomes +2. Oxygen is -2. There are 4 oxygen atoms. So, their total oxidation number becomes -8. We know that the sum of all oxidation numbers in a neutral compound is 0. Now the sum of the known oxidation numbers is -8 + 2, which equals -6. To make the total equal to 0, we must assign oxidation number +6 to sulfur. Therefore, sulfur has oxidation number +6 in H2SO4. Now, let us find the oxidation number of iodine in HI. Hydrogen is +1. We know that the total oxidation number in a neutral compound is 0. So, iodine must be -1. Therefore, iodine has oxidation number -1 in HI. Equation number 2. HBr reacts with H2SO4 to form Br2, SO2, and H2O. According to the rules, hydrogen has oxidation number +1. Oxygen has oxidation number -2. Br2 is a free element, so its oxidation number is 0. Now, the oxidation number of bromine in HBr is unknown. Let us find it. Hydrogen is +1. The total oxidation number of the compound is 0, so bromine must be -1. Therefore, bromine has oxidation number -1 in HBr. Now, let us find the oxidation number of sulfur in SO2. Oxygen is -2. There are 2 oxygen atoms. So, their total oxidation number becomes -4. We know that the total oxidation number of a neutral compound is 0. So, sulfur must be +4. Therefore, sulfur has oxidation number +4 in SO2. Equation number 3. V3+ reacts with I2 and H2O to form VO2+, I- and H+. According to the rules, the oxidation number of a free element is 0. So, the oxidation number of I2 is 0. The oxidation number of oxygen is -2. The oxidation number of hydrogen is +1. In ions, the oxidation number is equal to the charge on the ion. So, the oxidation number of V3+ is +3. The oxidation number of I- is -1. The oxidation number of H+ is +1. Now let us find the oxidation number of vanadium in VO2+. Oxygen is -2. There are 2 oxygen atoms. So their total oxidation number becomes -4. The overall charge on the ion is +1. We know that the sum of all oxidation numbers must equal the charge on the ion. So, vanadium must be +5. Therefore, the oxidation number of vanadium in VO2+ is +5. Now we will discuss how to balance a redox equation. Question A. Sulfuric acid reacts with hydrogen iodide to form sulfur, iodine, and water. Step 1. Find oxidation numbers. First, focus only on the atoms that change. If we look at the above equation, on the reactant side, the oxidation number of sulfur is +6 in H2SO4. On the product side, the oxidation number of sulfur is 0, so sulfur changes from +6 to 0. The decrease is 6. so sulfur is reduced. Now look at iodine. In HI, the oxidation number of iodine is -1. In I2, the oxidation number of iodine is 0, so iodine changes. From -1 to 0, the increase is 1, so iodine is oxidized. Step 2. Use the main trick. Increase must equal decrease. Sulfur change is 6. Iodine change is 1, so we need 6 iodines. Directly place 6 before HI. Now the equation becomes balanced for oxidation number changes. Step 3. Balance iodine. Left side has 6 iodine atoms, so the right side needs 3 I2 molecules. Now iodine becomes balanced. Step 4. Balance hydrogen and oxygen. Left side has hydrogen equals 8, oxygen equals 4, so place 4 water molecules on the right side. Now hydrogen and oxygen also become balanced. So this is the final balanced equation. Question B. Hydrogen bromide reacts with sulfuric acid to form bromine, sulfur dioxide, and water. Now we will balance this equation by using the oxidation number method. Step 1. Find oxidation numbers. First, focus only on the atoms whose oxidation numbers change. In HBr, the oxidation number of bromine is -1. In bromine molecule, the oxidation number becomes 0, so bromine changes from -1 to 0. The increase is 1, therefore bromine is oxidized. Now look at sulfur. In sulfuric acid, the oxidation number of sulfur is +6. In sulfur dioxide, the oxidation number becomes +4, so sulfur changes from +6 to +4. The decrease is 2, therefore sulfur is reduced. Step 2. Use the main trick. Increase must equal decrease. Bromine change is 1, sulfur change is 2, so we need 2 bromines. To balance the oxidation number changes, directly place 2 before HBr. Now oxidation and reduction both become equal. This is a very easy exam trick. Step 3. Balance bromine atoms. Left side now has 2 bromine atoms, so the product side needs 1 bromine molecule. Now bromine becomes balanced. Step 4. Balance hydrogen and oxygen. Left side has 4 hydrogens and 4 oxygens. On the product side, sulfur dioxide already contains 2 oxygen atoms, so we need 2 more oxygens. In water, place 2 water molecules on the product side. Now hydrogen and oxygen also become balanced, so this is the final balanced equation.